Hey, good morning, everybody. Today we're going to do Chapter 7, Section 3, repeating decimals. The first part is going to look at, here's our objectives. First off, we're going to look at why repeating decimals occur and how to tell if a decimal will repeat. Then we'll look at how fractions can be converted to repeating decimals and vice versa. Or how repeating decimals can be converted to fractions. Then how to order repeating decimals effectively. And then we're going to show that 0.99999, that's what that bar means there. It equals to 1. All right. So the first thing we're going to look at, why repeating decimals occur. Because the denominator does not go into the numerator a finite number of times. Right? For example, we have, say, 2/11. Yeah, in this section, I don't mind start using calculators the rest of the course because it'll make it much easier for us. So the old-fashioned way, we would do it this way. Does 11 go into 2? No. So we have to put a decimal up here. When you put a decimal up here, you put a 0 down here. So does 11 go into 20? Yeah, one time. 1 times 11 is 11. We subtract those, we get 9. Then we go to the next decimal. Does 11 go into 90? Yeah. 8 times 11 is 88. Subtract those two, we get 2. So that makes 20. 11 goes into 20 one time. 1 times 11 is 11. And we see we're repeating these numbers, 20, 90, 20, 90, which means these are going to be repeating forever. So 2 divided by 11 is 0.18 repeating. That's what it says. So it's always going to be 18, 18, 18, 18, 18. All right, so that's what it looks like. That's what's going to happen. Now, this block here, this number here, it's called the repetant. Because it's always, we know that 0.18, 18, 18. So 18 is the repetant. That's what's always going to be repeating. All right, so now the second part would be how to tell if a decimal will repeat. If a decimal will repeat. The simplest way to do this is by looking at the denominator. If the denominator does not does not, or if the denominator does not have 2 and 5 as the only factors, then it will repeat. All right, so if the denominator is anything other than 2 and 5, let's see what this means. So if we had 7 divided by 2, 2 goes into 7 3 times with 1 left over. So it's 3.5. 7 divided by 5. 5 goes into 7 once with 2 left over. So 5 goes into 20 4 times. 7 over 3. This one will 3 goes into 7 twice, so 3 is 6. We subtract those. 1. 3 goes into 10 3 times, which is 9. Subtract those. We get 1. 3 goes into 10 3 times, so it's going to be 2.33333333. It's always going to be the one left over. So it happens with any other denominator. So how do we convert? So if you factor the denominator, and get more than 2 and or 5, then it will repeat. Of course, yeah. I mean, if you take 7 divided by 7, that equals 1. Okay, so any other number other than the numerator. How to convert to a repeating decimal? So let's say 1 over 3 equals 0.3333 forever. Right? Now, we're going to look at this one in a minute because this one requires, because since all these go on forever, it's not a finite number. This one will require a algebraic process. Okay, let's say it's finite. So if we had, let's do something simple, 0.25. We know that we have 25. And then since the decimal's there, we have to move it 2 spaces to the right. So we have to put 2 zeros and the 1. Now we simplify. 25 goes into 25 once. 25 goes into 100 4 times. So 0.25 is the same thing as 1 over 4. Okay, how about 0.6? We know we have 6 over 1. That equals 6. But since we have to move it 1 decimal place, we have to put a 0 behind it. 2 goes into 6 3 times. 2 goes into 10 5 times. So 0.6 is 3 over 5. Remember I said earlier, if the denominator factors out to anything other than 2 and 5, since this is 5, we know it's a finite decimals. This one also, because 4 is made up of 2 times 2. Since it's only 2s or 5s, this is a finite decimal. How about if we had 0.425? We know the number is going to be 425. That's over 1, because that's what we're trying to get. How many decimal places? 1, 2, 3. So we put 3 zeros. And we start simplifying. So since these both end in 0 or 5, we know they're divisible by 5. 5 goes into 40 8 times with 2 left over. 5 goes into 25 5 times. 5 goes into 10 twice with 2 zeros behind it. Okay, 5 goes in there again because the last numbers. 5 goes into 8 once with 3 left over. 5 goes into 35 7 times. 5 goes into 24 times with a 0. 17 is a prime number, so we can't go any further. But remember, let's look at the bottom numbers. Let's see why it's a finite number of decimals. 40 is made up of 4 times 10. 4 is made up of 2 times 2. 10 is made up of 2 times 5. So the only factors we have are 2 and 5 on the bottom. So therefore, that's why it stops. All right, so far. Okay, so that's if it's a finite number. What if it's an infinite number of decimals? These are finite or terminating decimals. Those are our examples here. But what if it's infinite? Converting and a repeating decimal to a fraction. So we have 0.33333, and so on and so forth. So we have 0.3 bar, which means that. Here are the steps. 1. Multiply n by a tens number until you have the first part of the repeating decimal. Okay, so what is n? N is this number. So since this number has all threes repeating, we just have to move it one space. So we have the first of the repeating numbers up here. So we multiply both sides by 10, okay, so when you multiply it by 10, what you're doing is moving decimal over. So we have 3.3333 and forever. So that's what 10n equals. We have 10n equals this. We have n equals this. Subtract the number n minus your initial function value n. So in this case, we have 10n. If we subtract n from it, then we get 9n. So this is 3.333 dot dot dot. This is 0.333 dot dot dot. If you subtract those, what happens? All the decimals are gone. So you have 3 minus 0 is 3. Then solve for n. You have 9n equals 3. So we divide both sides by 9. 3 over 9 can be simplified. 3 goes into 3 once. 3 goes into 9 3 times, so your number is 1/3. And that's what we knew. Okay, let's do the same process, but with let's say our number was 0.24242424. Okay, remember the first step is multiply by some tens number. Since we have 2 decimal places, I have to move it because each of these, remember, we might repeat in 22.4, so let's move it 2 decimal places. So we multiply both sides by 100. So 100n equals 24.242424. That's that. So we take this one and that one. Subtract the tens number n minus the n. So it's 100n minus n. So 100 minus 1 is 99. What does that equal? Well, 100 is 24.242424 dot dot dot. Minus n is the original one. This is 0.242424 dot dot dot. So the decimals disappear. So we have 24 minus 0 is 24. Divide 99 to both sides. And we can simplify. 99 is made up of 3 times 33. 33 is 3 times 11. 24 is made up of 2 times 12. 12 is made up of 3 times 4. 4 is 2 times 2. So it's 2 times 2 times 2 times 3. So the only thing cancels out with a 3. 3 times 11 is 33. 2 times 2 times 2 is 8. So there's your fraction. Right, so that's how you convert a repeating decimal forever and ever down to itself. Ordering repeating decimals. Repeating or non-terminating decimals. The way you do this is, let's say the first number n1 equals 0.248765 and goes on forever. And the second number was 0.24877213. To figure out which one's bigger is keep on comparing the numbers until you get to the first non-similar number. Since 7 is bigger than 6, we know that the second number is bigger than the first. So since the 7 in the tens, hundred, thousand, in the hundred thousandths place is larger in N2 than in N1, N2 has to be bigger. To find a number between two repeating decimals numbers. Like this. First, find which number is smaller and by which decimal place. Example, N1 is smaller than N2 in the hundred thousandths place. And go to the next digit and add 1 to it. And that number will be between N1 and N2. Right, so that's all there is to that. The last thing in this section what was that? It was 0.9 infinitely repeating is the same thing as 1. Here's a proof. So n is 0.99999 forever. Since they're all repeating, all we have to do is move the decimal place over 1. So we multiply by 10 both numbers. So 10n becomes 9.9999. So take this number, the 10n, minus the n like we did earlier. 10n minus n. 10 minus 1 is 9n. 9.9 minus 0.999. The decimals cancel. 9 minus 0 is 9. Divide both sides by 9. And there you have it. It's a unique because it's called a round off. It's once you see the pattern, it's so infinitely close to 1 that it rounds up to 1. All right. So that's the end of 9.3.